Hello everyone, this is Mamta Ajay. In your 4th semester, I am going to handle first paper, that is paper 1 M401T, Measure and Integration. See, compared to fluid dynamics, it is just an abstract in nature. Anyhow, I'll try my level better to make you to understand. Now, before getting to the topic measure and integration, you just need a concept of basic knowledge regarding sets. So, in a set, for any given set, say X. So let me take a set X. So for every set, we can form a subset. Generally, a subset in the sense it contains a part of a original set. Fine. So suppose if you are going to write subset, remember pi is always a subset. Pi is none other than null set, and a whole set is also a subset. Again, an individual element A, B, C is also a subset. Again, AB is one of the subset, and AC is one of the subset. BC is also one of the subset. So we can form n number of subsets for a given set, right? And if the set contains all the possible subsets, we say that as a power set of a given set X. Power set is none other than it contains set of all the sets. Fine. Now, coming to the concept of measure and integration, this is what the basic thing you just need to know. Hope so it is clear for you. Now, coming to the concept of measure and integration, let me start with unit 1. In this paper, you have totally 4 units. In each unit, you will get 2 questions. As in the fluid dynamics, it is also same. You have 4 units. Among 4 units, in each unit, you will get 2 questions. So let me start with unit 1. In unit 1, the first topic is that algebra of sets. Algebra of sets. It is just a basic thing. Anyhow, it was asked in the year 2018 for 2-mark question. Define algebra of set. Suppose if X is any non-empty set. Then if A is a subset of X. You are already familiar with subset now. A is a part of set X. If A is subset of X, then A is said to be algebra of X. A is said to be algebra of X if it satisfies 2 conditions. First condition is that A should be closed under complementation, or we can say complement. A is closed under complement. Second condition, A is closed under finite union. See, first condition, A is closed under complementation. In the sense, suppose since A is subset of X, right? Suppose if any element, say B, just in order to avoid confusion, let me take an element B. If suppose I have an element B in subset, say A, then its complement, that is B complement, we generally represent it as B complement, should also belongs to A. A is closed under complement, meaning is that for any element in a subset A, its complement should also belongs to the subset A. Then we say A is closed under complementation. Fine. Similarly, A is closed under finite union, meaning is that if you're going to consider 2 elements, say B1 and B2, then their union should belongs to the subset A. B1 union B2 should belongs to subset A. Then we say A is closed under finite union. So if both the conditions satisfies, then we say A is algebra of a given set X. It's just a basic definition. A is said to be algebra of a given set X only when it satisfies 2 conditions. First condition is that A is closed under its complementation and A is closed under finite union. Fine. Now the second concept, sigma algebra. See, I cannot explain all the theorems in depth. All the basic terms should be in your mind. I'll try my level better to convince you. Now the second concept is sigma algebra. Fine. When do we say for a given set X, when do we say A is a sigma algebra of X? Sigma algebra of X. The same thing. Algebra of set is none other than sigma algebra. We say that as sigma algebra. That's all. Only when it is main thing is whether it may be closed under complement or not, it should closed under finite union. Countable union. I should closed under countable union. The difference is that in algebra of set we say it is closed under finite union, whereas in sigma algebra we say it is closed under countable union. So a subset A is said to be a subset of A of a given set X is said to be sigma algebra only when it is closed under countable union. I'll give you an example. Suppose if I have a set A with an element say ABC, and let me write set A with an element say AX, ABC. Suppose if this is one set, subset I can say. Yes, of course it is a set. A is a subset of X clearly, right? It is a part of a given set. A is subset of X. Do we say A is sigma algebra of X? My question is, do we say A is sigma algebra of X? Yes, it is. Why? Because it is closed under complementation and finite union, or else countable union I can say. See here, subset A has an element pi, in the sense null set and a total set and an element A. So here I have written the same set. Look at this set ABC. So these are all possible elements in a given subset. Fine. So A is clearly subset of X. Why? Because it contains all the elements in a subset. Right. So if you're going to take any countable union, since the elements is countable, so that is the meaning. Countable union in the sense, if you are going to take union of any two element, that should be countable. Countable and finite is one and the same to some extent. Why? Because when do we say countable? In general, any set is countable when it contains finite number of elements. It doesn't make more difference. When a set contains countable number of elements, we say it is a finite set. Or else I can say when a set contains finite number of elements, it is countable. That's all. Just a logic you just need to understand. Fine. Now A is clearly subset of X. If you are going to take union of these two sets, what you are going to get? A, I am going to consider this set and this set. Elements. So if you are going to take a union of these two elements, you will get ABC. Again, ABC is none other than set X is also in A. I'll repeating once again. I have taken a set X as an element with an element ABC. Now I have constructed a subset A of set X which contains an element something like this. If you are going to take union of these two sets, you will get ABC. ABC is none other than a given set X which is again in the given subset. Therefore, we can say A is sigma algebra. A is sigma algebra of given set X. Is this clear now? I hope it is clear for you. Now, let me tell you key points which you need to remember for further theorem's proof. Remember, when X is a set and A is subset of X, is said to be sigma algebra when sigma algebra in general, sigma algebra when it is closed under complementation. In the sense, when you're going to take complements, that should be belongs to the given subset, as I said earlier. And second condition is that it should be closed under countable union. Countable union. Fine. Now, coming to the properties of sigma algebra. First property is that an algebra A and set X is closed under finite intersection. Finite intersection. Here you will get a clear picture of finite and union intersection. Countable intersection. An algebra A and a given set X is closed under finite intersection. It is one of the property of sigma algebra. Suppose, let me take A is a algebra. A is algebra on set X. I have considered a set X and A is algebra on X. So as I said now, whenever we say A is an algebra, that is sigma algebra, only when it is closed under its complement, and second one, it is closed under countable union. Let me take any two elements belongs to a sigma algebra. Fine. A and B are an algebra. It is not an sigma algebra, an algebra. Remember, when you talk about an algebra on A, you are talking about finite intersection. Similarly, when you talk about sigma algebra, remember, the term will become, finite intersection will become countable intersection. Countable intersection. The difference is that when you have only algebra, you will be getting finite intersection. When you have sigma algebra, you will be getting countable intersection. Now, I have chosen two elements in a given set A. So, since A is an algebra, so it is closed under its complement. In the sense, its complements is also in the given subset. So, A complement, B complement also belongs to A. And it is closed under finite union as per the sigma algebra. See here, algebra of set definition is it should be closed under its complement and it should be closed under finite union. Now I am proving the same for finite intersection. So I have chosen two element in A. Since it is algebra, so it is closed under complement and closed under union. So its complements belongs to the set and its union also belongs to the given set. So since its union belongs to A, now let me consider this as a single element. So its complement, in the sense A complement, union, B complement, whole complement also in the given set A. Now apply the De Morgan's theorem. So you will get A complement intersection B complement also belongs to A. De Morgan's law, I hope you remember the basics. Right? So what De Morgan's law says, like A union B whole complement will be equal to A complement intersection B complement. When you are going to apply De Morgan's law, you will get something like this, right? Again, A complement B complement belongs to the same set, right? So I can write A complement whole complement will become A, intersection B complement whole complement will become B, belongs to A. So it is closed under finite intersection. Is this clear? So I have chosen two elements in a given set A. So since A is algebra, as per the definition of algebra, it is closed under complements and it is closed under its union. So its complement also belongs to the given set. Subset, and its union also belongs to the given subset. I have taken this as a single element, so its complement also belongs to the given subset. Now apply the De Morgan's law. A complement whole complement will become A, B complement whole complement will become B. So its intersection also belongs to the given subset. So I have proven it is closed under finite intersection. In the sense, intersection of the same elements AB, intersection of same elements AB also belongs to a given subset A. Now second property is a sigma algebra on X is closed under countable intersection. Countable intersection. Both are looking like same, but they are not exactly. See here, I have written an algebra on A, finite intersection. Here I have written sigma algebra, countable intersection. When you are writing sigma algebra, you have to use the word countable. When you are writing algebra, you have to use finite. Right? One and the same. I have already told you. When you have finite number of elements, it is countable. When you have countable number of elements, it is finite. But you have to, while writing, you have to take care of words. Now, a sigma algebra on X is closed under countable intersection. The same thing. Now, let me consider A is sigma algebra, right? It is already given. So it is closed under, I have already told you, as per the properties of sigma algebra, it is closed under countable union. In the sense, union of elements is also in the same subset. So I have taken two elements. Let me take that as capital letter A1, A2 and a given subset A. Since A is a subset of X here. Now, A1, since A1 A2 belongs to A, since A is sigma algebra, so its complements also belongs to the same set A. Now its union, since it is closed under countable union, I'm talking about countable union. So its countable union is also in the given subset. Now let me consider this as a single element. So I can write A1 complement union, A2 complement, whole complement is also in the given set. Now apply De Morgan's theorem. So you will get A1 complement, whole complement, intersection A2 complement, whole complement belongs to A. So what it become? A1 intersection A2 belongs to A. In the sense, it is closed under countable intersection. I have used the property of countable union here. As per the definition, it is closed under countable union. So I have used this property and I have proved that it is closed under countable intersection as well. So these two are the properties of an algebra of set and sigma algebra of set. The difference is that in algebra of set it is closed under complement and it is closed under finite union. In sigma algebra it is closed under complement and it is closed under countable union. Make difference here, it is finite, here it is countable union. It is just a basic concept, you just please go through it, and the theorem based on this will be continue in next session. Thank you.